Okay, I've showed you area model using these models. I've shown you the distributive property and partial products to solve multiplication. And today I'm going to teach you the last method that I am going to teach you of how to solve 2 by 1 multiplication, the traditional algorithm. So the traditional algorithm is the kind of like the way that you would use once you're understanding what we're actually doing. These are very conceptual, meaning they really explain to you how we're multiplying. They break it down with the place values. You're putting your numbers in expanded form. The traditional algorithm doesn't ask you to do that. It asks you to make it a little bit less complex, a little less about place value and a little bit more about getting the answer right away. So I'm going to go ahead and show you really quick on this sticky note. So here is how our traditional algorithm works. When we're using it, we need to stack our numbers, okay? We need to stack them on top of each other, keeping place value in mind. Place value is still important in these problems. So what we're going to do is we are going to start with the bottom number, starting with the ones place. 4 is going to be multiplied by each place value here. Just like we do here. We are multiplying by every single place value. This 4 is still being multiplied by this 1. This 4 is still being multiplied by 20. However, we're not necessarily going to do 4 times 20. We're going to make it a little bit different. So first I'm going to do 4 times 1, and I'm going to write down my answer, 4. Then I'm going to go ahead and I'm going to multiply that 4 times 2. And I'm going to get 8. Okay? This would be the same thing as if we did area model or partial products. So in this case, with area model, 4 times 20 gives me 80. 4 times 1 gives me 4 equals 84. Okay? 20 times 4 plus 4 times 1 with partial product / distributive property. 80 plus 4 gives me 84. I got the same answer. I just did it 3 different ways. Okay? So in this case, I'm just not showing you explicitly how I'm breaking up the numbers. I'm just breaking up the numbers into the different place values with expanded form. I'm just doing it in these 2 steps. Okay, so we're going to go ahead and practice the traditional algorithm today. If at the end of this you're like, I really prefer partial products or I really prefer the area model, you're more than welcome to make that your expertise. I'm just showing you one last method. So let's go ahead and do the problem. 32 times, let's do 32 times 4, okay? So my first step, and I'm going to show you this with different colors, and if you don't need to draw these lines by the time I'm done with teaching this to you, then don't draw the lines. So I'm going to multiply this bottom number by every top number, starting in the ones place. 4 times 2 gives me 8, okay? And then I'm going to go ahead and I'm going to do 4 times 3 gives me 12. And I just go ahead and write my 12. There's no more numbers to multiply, so I can just write my 12 right there. And I get 128 as my answer. Okay? Let's try another one. Let's do 23 times 3. Okay? You might be able to do this in your head, but I still want you to practice using the traditional algorithm. Go ahead and practice using the traditional algorithm now. Okay, so my first step is to do 3 times 3, which gives me 9. And my second step is to do 3 times 2, which gives me 6, 69. Okay? So let's go ahead and do Another one. Let's do 92 times 4. Okay. My first step, try it yourself first. My first step is to do the 4 times the 2, which gives me 8. And then 4 times the 9, which gives me 36. So I'm going to draw that right here. And since there's no more other numbers to multiply, I can just drop that down there. All right. Let's do a word problem, and then we'll go ahead and call it good. So the school cafeteria, oops, you can't see that. The school cafeteria has 4 rows of tables. Each row has 22 seats. How many students can sit in the school cafeteria at the same time? Okay, the school cafeteria has 4 rows of tables. Each row has 22 seats. How many students can sit in the school cafeteria at the same time? So 4 rows times 22 seats. I'm going to stack this so that I can solve it using my traditional algorithm. 4 times 2 gives me 8. 4 times 2 gives me 8, so I can say that 88 students can sit in that school cafeteria at the same time. All right, that's all I have for you.